Hi, I'm Rich Hill. I'm the CTO for Aquila. This video is an introduction to software-defined networks, which is a technology that underpins the Aquila solutions. So what is an SDN? Well, it stands for software-defined network, and it's very similar to cloud computing, except that instead of virtualizing servers, we're doing it for connectivity. So we have a virtualized network solution. This includes virtual switches, VLANs, central control. It's highly scalable and secure, and it's optimized with AI. Essentially, all the benefits that you're accustomed to through cloud computing are now available for cloud or virtualized networks. This is the standard OSI data model. We're only really concerned with layers 2 and 3. Existing products such as SD-WAN and VPN operate at layer 3, and MPLS is somewhere in between at layer 2.5. Aquila is the only solution that operates at layer 2, and this has got lots of advantages. Essentially, we're creating a global network that is the same as being in the same office. So we're connecting multiple sites and multiple hybrid users into one layer 2 network. So how do we do this? Well, it's via our Virtual Extended Network Protocol, or VEN for short. We take standard layer 2 traffic, chop it up into small bits, encrypt them, and then transmit them over TCP/IP. By default, we have 8 streams of data, but this could be just one, or it could be up to 32. It's configurable. There are 2 main advantages of doing this. The first is that by using 8 streams of data, they are resilient. So if 1 or 2 of them drop out, there's no interruption to service. We basically operate in a similar manner to RAID, and we stripe the data across those streams. Also, it grabs more bandwidth. So something that happened often during the pandemic is that home workers were having really poor connectivity because the kids were playing on the PlayStation or watching Netflix, and this doesn't happen. It's essentially the same as being at home, but having 8 computers all connected together. So you hog that bandwidth and get a much stronger connection. Obviously, you're still limited to whatever service you get at home, but you get a much larger portion of that service or bandwidth. And then we do exactly the same thing in reverse, and it comes out at layer 2 traffic at the other end. Now, obviously, this diagram just explains the process sequentially, but in reality, it goes in both ways. It's bidirectional. So to recap, the Virtual Extended Network Protocol is layer 2 over layer 3. It has multiple streams of data, which gives bandwidth grabbing technology and low latency. It also works really well over traditionally difficult circumstances, such as 4G, 5G, and satellite. It's also really low overhead for encryption, just 0.5%. And the reason for this is that we're operating at layer 2, not layer 3. So let's see how it works in practice. Here we have our main data center or head office, and the Aquila service connected to existing servers and printers, etc. We have hybrid users, and they need to have the Aquila client software installed. This comes in multiple flavors, Windows and macOS and Linux, but also for mobile, so iOS and Android. Let's take Windows as an example. The drivers are signed off by Microsoft, and they boot in kernel mode. It's essentially the same as having a virtual network card. As soon as a user opens up their laptop, they're connected to Aquila even before they log into Windows. Remote or satellite sites work slightly differently. Instead of having to install the client software on each device, we use a bridge, and that bridge will connect up the entire network. So this can be just, as I say, normal computers, printers, file servers, but it can also be any sort of IoT device, such as security cameras, HVAC systems, or even a Bluetooth thermometer. Anything on that network will be connected via the bridge into one large global extended layer 2 network. We also have an option for failover for disaster recovery. So if you have a separate data center ready for disaster recovery, and someone drives a bus into your main office or data center, then within 5 seconds, everything switches, and the disaster recovery center becomes the main data center. There's no loss of service apart from that initial 5-second gap. Hybrid users and remote sites don't need to change IP addresses or configs. Everything just gets handled automatically. So let's go over the advantages one more time. Equivalent is layer 2 over layer 3, centralized provisioning, high rapid scalability. It's very secure with a very low 0.5% overhead for encryption. From early 2023, we're going to have quantum encryption as an option as well. This is a hardware solution using lasers and photons. It has very high entropy, which means the quality of the random numbers is better. So it's harder to guess the keys, almost impossible in fact. Reduced hardware footprint. You don't actually need hardware at all, although it is an option for convenience, and it's AI optimized. This bit's a little bit like teaching people how to suck eggs in terms of what it can't do. At home or in the office, you still need to have your Wi-Fi router or switch to physically plug in your Ethernet cable into the back of your PC. Otherwise, everything else is virtualized. It's a replacement for VPN, SD-WAN, and MPLS. We're layer 2, not layer 3 or layer 2.5. We're much more competitive on price. VPN is very unreliable. Often people log several support calls. That's not required for Aquila. It's an always-on solution and it's incredibly stable. SD-WAN and MPLS require hardware. There's no option to only have software, and there is currently a big delay in getting that hardware. We do also have hardware options, but we have plenty in stock and are able to fulfill requirements very quickly. Aquila comes in 2 flavors, cloud and enterprise. The main difference here, or the analogy here, is buying clothes. Cloud is off the peg, you walk into the store and you can get it within 5 minutes. Enterprise is a bespoke solution tailored for companies and organizations. Cloud is suitable for smaller companies. It's hosted on Azure. There's a web portal that's really clean and easy to use. People can literally add devices and bridges and be set up within minutes. There's a no long-term commitment. It's a simple monthly contract. People simply pay for a device or a bridge on a monthly basis. Enterprise is for large companies or organizations. It's self-hosted. There's more about that on the next slide. There's a Windows portal. As hinted at, there's a lot more options. It's completely custom. So you can have multiple virtual switches. You could integrate for authentication purposes with Active Directory. Lots and lots of different things you can do that aren't available to cloud. It's an annual contract. In practice, companies normally ask for a 3 or 5 year quote because when they change their network infrastructure, they want to do it again a year later. Consequently, the pricing is bespoke. It's down to the requirements and the needs of the client. And typically, we work with them to do the network analysis and work out exactly what they need. In terms of installing enterprise, there's both software and hardware options or hybrid. You can mix and match. So for software, there's Windows, Linux, and VMware. And for hardware, there's 3 different sizes. The 500 is often used as a bridge. It's quite small, probably the same sort of size as a home broadband router, and it's easy to use. There's also a web portal for configuration. The 3500 and 7500 are for large organizations which require higher capacity and throughput. They're rack mountable, they'll go in a server cabinet, and they also have a lot more Ethernet ports on the back, so you can have multiple WANs. That's it, that's the overview. Hopefully that's useful. If you're interested, please contact us. Thank you very much.